Hello and welcome to this video. In this video I would like to be talking about CPUs and threads. We spoke about the embedded systems and ARM processors and all sorts of things, so hopefully we've got a good idea about the CPU in general. But with a CPU you'll often hear it has, it could say 16 core and 32 threads. What does this actually mean? The best way to describe it is probably by drawing some pictures, unfortunately, of a CPU. Now, I won't do a 16 core one because it is too much. Let me just do, you could have, let's do 4 cores. So what I'm saying is that this here is the CPU, but within inside that we have cores. Now, sometimes these are confusingly called CPUs as well, because technically they are. This is one CPU effectively. This is one calculator. This is one thing that can do computation. This is another one. So on this one I have 1 to 4, and that's all well and good. That means I have 4 processing units. Well, okay. Let's look at one of the older CPUs, like some of the Pentium ones I was talking about. And let's say I think they come out in around 2002, 2003 maybe. I'm not too sure, but it was quite a while ago. So this had 1 core. Now, single processors are okay. They're fine, single core is 1 CPU, but that means that basically you can do 1 calculation at a time. So if I have a graph here, you might want to do your inputs, so your processes, process. So this is time here, let's say every second, for example. Well, process 1 goes here. Then you would be able to do process 2 at another time, and then process 3 down here. You couldn't do all these at the same time. This is with 1 core, right? So 1 CPU. It's got one thing that can compute basically. Now, if we go down to, let's do it in a different color. If we look at a similar graph of when let's break it down. When we have a 4 core, for example, or a 3 core, or a 2 core, whatever, more than 2 cores, basically. When we have 4 cores, we have our inputs, and now what you'll see is that I'm able to do 1 calculation on one of the cores, another calculation on another core, and another core, and another core. So it's effectively doing several things at once. I could do, this is a 4 core one, so I could do process 1, I could do process 2, I could do process 3, and I could do process 4. Now in reality this is probably going to be 1 instruction broke down. So in other words, it would probably be just 1 task that's been broken down into subtasks. But we'll go through this in the operating system tutorials. But just for the sake of argument, let's just say that every core is like 1 CPU. So 1 core equals 1 CPU. So if I have 4 cores, then I can do 4 tasks at a time. I can do 4 things at a time. I can compute 4 things. So what we had up here is this picture of our cores, and I'll just redraw this a little bit down here. Now, this is where the threads come into play. So I'm going to just draw these 4 cores again. And a thread now would be inputs into each one of these. So effectively, I could input a channel there. So that's 2 channels, by the way. Each one of these are a channel. Let me do it in a different color. Each one of these are a different color. So I can have these inputs, And these inputs, well, of course, they'll be talking in binary, right? They'll be talking in ones and zeros, etc. And these will be talking in ones and zeros, and it'll be getting fed through. So I can think of this as a processor. So these cores are doing operations. And remember we had this input box, this multiplied by 10 business. We had a 10 over here, and then it outputted hundreds for us. This is like a function box, as it were. Well, actually, these CPUs are coded. They're created. Sorry, they're not coded. They're created so they can do more than just multiply by 10. But let's assume for now, for brevity's sake, that they can only do multiply by 10. And now I can basically put different numbers in at once and multiply that by 10. Now these things here are called a thread. It's important actually to note that the cores, a core is a physical thing. It's a physical thing, which means that you could see it, right? They are physical cores. So you would assume a 16 core CPU would be bigger in size than an 8-core CPU and a 4-core CPU, because they physically take up room. Whereas threads, they're a bit more of a logical core, and they are sometimes referred to as logical cores. So what we're going to talk about is more in depth on how the threads work, but the idea is simply that threads just are inputs and outputs, whereas a core is a physical processing unit. They're two different things. Now, the thing is with cores is if I have one single core, like I had before, if I had a single core, then I get the processor to process really quickly. But as I get it to process, it increases the heat and it increases the amount of electricity I use. And remember all of the ideas we were talking about, electricity. Remember all the ideas we had about the CPU efficiency. This is where it really comes into play here, because one core, you would have to hire up all the the heat. It would be very inefficient. You'd have to clock it a lot quicker. So this 2.4 gigahertz business, you can overkill that, right? It starts becoming inefficient. It starts actually slowing the CPU down effectively. So we don't want it to be 10 billion calculations to 10 gigahertz, because it make the CPU, it would heat up so much so quickly, it would actually just mess around with the electrons and things like that. I don't want to go too much into the physics of it, but it would mess around with things like that. So the other thing there then is that we could have a 2-core unit. We could clock them at a relatively good speed. So let's say we put them both at 1.8 gigahertz, which is a relatively low speed. I could then run the same efficiency. I could run a program on a much lower clock speed, if that makes sense. So to run one program, let's say, I don't know, I want a word processor. To do that, I might need to use this at 3.6 gigahertz or higher probably. And with the word processor on this, perhaps I only have to run it at 1.8 gigahertz. So these are the differences. Now the threads in itself just allows you it allows the CPU, so the cores, to just do different things whilst it's paused effectively. So the input is going into the CPU, so that's one thread. Then sometimes you might get stuck. It might have to pause a second whilst it calculates or retrieves more information or gets some more information from the memory, or there's loads of different things going on in the CPU. So whilst it's paused, it can't do this anymore because it's waiting for another calculation to happen somewhere else. It's waiting for more input. It's waiting for a time or an error code to be checked or something. So whilst it's waiting here, whilst this input 1 is waiting here, and this is a thread, by the way, all of this, these arrows is one thread. Well, we had 2 threads going in there. So actually, whilst that's paused and waiting for the error checking or waiting for something else to happen, we can actually start feeding it through another input 2. And this is another core, sorry, no, it's not another core, this is another thread. So this is thread 2. So you can see how it logic, and they can't run at the same time. CPUs can run at the same time, so the cores can run at the same time, but threads can't. They have to stop. Thread 1 has to stop. Let's say this is thread 1. That has to stop before thread 2 can take over. So these threads are this idea of being able to switch inputs effectively, which is quite useful for something called concurrency. We'll be going through more about the concurrency, and I'll go back to the threads in the operating system level, and I'll use it under operating system because it's the operating system that's deciding what's happening here. I don't want to get into it too much, but just know that the operating system is the boss of all of this. It does all the multitasking effectively. So I'll stop the video there. I appreciate that was a lot of information. I hope that it's been useful, and I'll see you in the next video.